Okay, I'm going to continue on exception. Try to make it smaller. Okay, so exceptional handling is probably the last topic I'm going to cover in depth. And then we're going into the final project mode and the rest of the topics such as GPU programming. But I want to talk about exceptional handling because exceptional handling is very useful in writing large program. So let me repeat what I have talked about so far. So this is the basic idea about 3 keywords you should learn. One is called try, which is a try clause, so try block. And then follow the try is one or more catch. Okay, so it's one try with one or more catch. Inside the try, you have directly, you might have a throw statement, or you might not have a throw statement, but inside one of the function that's being called multiple layer, I don't know, could be 2 layer, 3 layer, 4 layer, it depends. It's all possible that one of the deep down there function is going to have the statement called throw. So essentially you can think about, I look at a piece of code. If any instruction in this piece of code is generating a throw statement, then my catch statement hopefully can catch. It's like a baseball. By the way, hey, wait a minute. This is like a baseball. I mean, in Taiwan, we love baseball, right? So essentially when I say try is I actually allow the pitcher to be anywhere in this block of code. And so when the pitcher detects some condition, it's actually going to generate a throw statement. So you can think about a baseball is coming up. And then the catcher has to basically catch it. If the catcher didn't catch it, that means you're going to get uncaught exception. Then you have this abort trap 6 statement coming up. So I mean, how do I know that the catch statement can catch that baseball? It's based on the type. So essentially when you throw, you're actually throwing an object. It could be a complicated object like a GPS DD. It could be throw a person object. It could be throw a integer, which is a simple object. But the catch need to be exactly match the object type you throw, or this catch is the base class of this object that throw. Okay, so then we have to think about inheritance over here as well. So throw and catch need to match if they're exactly identical or they have a inheritance relationship. So the base class catch clause can catch anything that's inherited from this base class, the right class. Okay, so this is a basic idea. I mean, last time we showed you a piece of code, which is I use this set GPS label to tell you that you can throw. I mean, in this example, it doesn't make sense, but I'm just telling you, you can throw anything. For example, over here in the set GPS label, I decide to throw a baseball, which is the type is GPS DD. I throw a GPS location. And then the catch, the first layer catch, the closest the catcher is the kind of baseball he can catch is JSON RPC exception, which is not, doesn't have the it's not exactly the same. You know, also not the base class, derived class relationship. So sorry, this one failed to catch it. But in my main function, which is the main function actually call this function. So even though I have a try clause here, but the real pitch, the real throw statement is actually hidden inside this function I call. So that's why I want to tell you. Another thing is that it might not be generated by your code. but it might be the exception might be generated by the library call that you actually invoke. But over here, you see I have a catch statement, which exactly catch GPS DD baseball. And therefore, this one will be catching this particular throw statement. So you can see, think about the throw statement is inside set GPS label, but the one who actually called it is actually in the main function. Okay, so this gives you a very interesting way for you to decide a control flow transfer. Okay, this is a very hard topic. Okay, so you have to listen to me for a moment because this is now is interesting. Usually when you have a program, when do you actually return the control back to the main program? When you make a call, shadow GPS, set a label GPS, and then you are supposed to execute every single line until you hit return statement. Then it's supposed to return over here. But there's one important property about exceptional handling is that as soon as you hit this one, throw GPS ED, immediately he stopped going through the rest of the code. So essentially you see that you're designing a whole program, but it's actually jump out immediately. So it actually jump out and neglect everything after this line, but it directly jump to over here statement. So it's a big jump. So exceptional handling is interesting. It can catch a throw, but it also change your control structure. It changes your control structure because you write a piece of code. You have to imagine at this moment, hit certain condition, your code is going to jump out of this function, even though this function hasn't really finished. You need to pull yourself out and directly go into the catch clause. And then you finish the rest. So you skip anything between this line and the end of this function. You skip everything after the shadow GPS set level within the same try block. I mean, I'm assuming over here you have other code. And it will directly jump to the catch clause. And then it will continue at this point until it finish or until it hit another throw statement. Okay. So okay, just want to clarify two things you need to learn. The basic syntax is try, throw, and catch. That's lesson number one. Lesson number two, you have to match the type. Each of the catch clause has a type which is supposed to match the type of baseball that you throw. Number two. Number three is a big jump when you're using exceptional handling, meaning that the code is not following the original flow chart about how you think the code is going to executing and direct jump. Let me give you an example. This could be really interesting. I mean, you probably heard the idea of a sorting, right? You should learn the idea of a bubble sort, right? You think about, learn about bubble sort. So what is a bubble sort? Bubble sort is an array of elements. They're in random order, but you sort it, follow, say, alphabetic order. Okay, assuming you hit a throw statement in the middle of sorting. So you actually sort about 70%. That's actually follow the order. But then there's the other 30% is unsorted. So you think about your progress, it's a sorting, 70% sorted, 30% unsorted. But then you hit the throw statement, which means you're going to jump out of the bubble sort and then continue to execute. So that's very tricky. Think about what will happen is that, well, what happens to that array? You try to sort. It's only 70% sorted. So how do you actually handle that? The trick usually for the data structure is that if you know what's going on, you need to know at the catch statement inside here, you need to know this is actually the throw statement is actually related to a failed attempt to sort an array. And therefore, inside here, I will resort it because you need to remove the whatever condition causing the exception. But over here, you should be able to still access to that array. And then you need to resort the array to finish the job before you can move on. So that's why the catch statement is supposed to recover everything that's half finished. And you need to do that. So the design of exception is very powerful. Sometimes unnecessary. I will tell you that why sometimes it's unnecessary. As any feature of programming language, it has a purpose, but it also sometimes could be overdone, that you shouldn't use that feature. But that's the 3 lessons. Let me actually write it down before I move on, because I think this is important before I teach you any further on this subject. So let me tell you 3 things you should learn about exceptional handling. The first one have 3 statements: try, throw, and catch. And then it has to be typed object, either exact match or inheritance. And the third thing is big jump. That you need to, the control shift from the normal execution to the whatever to handle the exception condition. The final thing is in the catch clause, you might need to recover. The example is 70% done bubble sort. Okay, this is the things I just covered about the basic idea about exceptional handling. I want to make sure that you remember all those 4 issues, because if you want to use exceptional handling properly, that those are the basic you need to know. Okay, any question before we look at the next subject on exceptional handling? Okay, we're going to go into the detail about exceptional handling right now. Okay, I actually want to talk about this. This is the interesting part. So one of the idea, okay, this is my way of teaching programming language. So I feel that at one level, I will just tell you what is the feature in the programming language. But I typically like to ask all of us, including myself, all the time, why do we need to use this feature? If you look at your textbook in C++, it's getting thicker and thicker. By the way, the first time I catch a book in C++, it's about 1/3 about the thickness about your textbook, which means that there's a lot more stuff being added to the language. Okay, so we have to think about why do we need to use exceptional handling? I want you to think about this, okay? Think about this. So, I mean, there is, okay, maybe before I tell you the answer or my opinion, not answer, okay? I don't like to use the word answer, because in programming language, usually there's no correct answer. It's just opinion about a particular language feature. It's just like in English or Chinese, why in this situation you should use this phrase versus the other phrase. There's no standard answer. Okay, so the first question we always challenge to ourselves is, why do we need exception? I mean, you can replace this exception as inheritance. Why do we need inheritance? Or why do we need multiple inheritance? Or why do we need JSON? Okay, so everything should have a reason, and you should think about that, you should understand that. So why do we need exception based on the way I just present to you over here? Why do we need this? Anyone want to try to provide some of your opinion? Or maybe your answer is no, we don't need exceptional handle. Why do we need exceptional handle? Okay, I mean, since you guys are so humble, I believe you all know the answer, but you just don't, you feel a little bit shy, you don't want to answer. So, okay, let me try to probe your answer out. So I try to make an argument. Okay, you guys need to argue against me. Okay, let's try to play this game. My argument is we don't need exception. I can write program better or as good if I don't use exception. So I make that argument. Do you believe me? Okay, I'm going to use this example. Remember, I have this code. Okay, let me show you what I did last time, and then we can actually go back to see why I said I don't need it. I'll use this as an example. Great. Okay, I have the two program. One is a server. I'm going to run the server first. And then I have to run the client. Okay, you can see that I have a client server, and inside the client program, I generate exception. And then you can see I caught the exception. I caught you see that here is the line I said I am in PO client.cpp. I'm using exception handling to generate this line. I just highlighted here. So now I'm going to supporting my own argument. I said I don't need exceptional handling, which means that I can accomplish exactly the same result without using try, catch, and throw, right? I basically have a way to do that. So let me actually try to do that. That's interesting. I never done this before, but this is good for me to exercise. So first, I have to go to set GPS label. So this will be label gps.cpp. Is this set label as GPP? Yes, it is. No, this is, I need to go to the shadow because it was a shadow version. I have to go to shadow gps.cpp. Okay, inside shadows.gpp, remember this is a proxy object. So this is the place I generate exceptions, set GPS label. Inside here, I have a try clause. And then over here, where's my throw statement? Anybody can show me where's my throw statement? Here. You see, I have a throw statement, star GPS underscore PTR. So, okay, now I see my throw statement. Okay, so I'm throwing something, but it's not being handled correctly. Okay, I'm going to do this. So I'm going to, I need to, basically the throw statement, I need to pass this pointer or this object back to the main function. So how do I do that? So one of the way I can do this is I have to change the argument. So I'm going to change the argument and change this argument to be a GPS dd star return. So I'm going to return that. So I'm going to add a new argument. And then I can get rid of try because I don't want any of this. And I'm going to get rid of this. And I'm going to, instead of doing this, I would say return PTR is equal to GPS PTR. Okay, you see that? Instead of throw, I'm actually specifically, I add a new return, a new argument for the purpose of returning. And then I just set that value to be there. And then I get rid of this part. I get rid of all the catch stuff. Okay, and the rest will be just like this. Okay, so of course, because I make this change, I have to modify .h because now I have to return the set GPS label. So I can do here over here, I have to say GPS dd star. But because I do this, I have to include, oh, I already have a label GPS, so I should be fine. All right, so this part, I modify this. And let me try to modify the PO client. Now I'm modifying PO client. And I'm going to, everything is fine, except this part is fine, this part is fine. Okay, I have to get rid of a try. Remember, I have to get rid of a try. I don't like this. Okay, over here, I'm doing set GPS label, but over here, I'm going to do, let me see, label GPS. Okay, so I have to do one thing. I have to modify because I need to have a Boolean return. I have to say bool RCB is equal to label GPS PTR, set label, but then I need a second argument, which is, I will call it a GPS PTR, because now I need two arguments, and that's why here I need to have a GPS PD star GPS PTR. And then over here, because I did that already, I have to say RCB is equal to true. And then the rest of the code, I have to catch this one. Okay, I'm going to do a little bit trick here. I will show you what I did. I'm going to say is equal to null. If GPS PTR is not equal to null, meaning that it has been set by the exceptional handling, which is the now is no longer have exceptional handling, I'm going to do this. And I'm going to get rid of this one as well. Get rid of try, get rid of catch, get rid of printf, get rid of this part, get rid of this part. Okay, I'm going to do this. Let me try to compile. Hopefully it doesn't, oh, I have error, too many argument. Why is this? Let me do a make clean. I think I know what happened because I have to modify label GPS as well. I modify shadow GPS, but I need to modify label GPS.h. That's why I have to modify multiple place. Let me see, set GPS label. Now this has to be GPS PD star. And then CPP, I have to modify. Where's set GPS label? Set GPS label here. Okay, so this is This is actually under PO client. So should be GPS, and this should be true. Oh, GPD, that's which one? Oh, shadow GPS. Shadow GPS. CPP. GPD. Wait a minute. Another one. Oh, this one is line 83. Okay, that's a server side. I don't care about the server side. Okay, it's okay. I'm going to run the client side. I mean, the server side, yes, I actually need to fix that, but I don't want to fix the server side right now. Let's just fix the client side. If I run the client side like this, you see that? I'm actually only, oh, it doesn't generate that for me. The result is true. It must end somewhere. I'm sorry, I make it too simple. I probably make it a little bit more complicated than this. I probably have to fix this. PO client. Oh, I know what happened. Um, Emacs shadow GPS.cpp set GPS. I do a new over here. Yeah, I actually put it in. Why didn't work like this? Okay, I'm going to make it return. Yes. TURN. I'm just going to return here. I'm going to make it easier. Okay, I'm not going to worry about the client server. I'm going to not worry about the client. Uncaught. I know why. Because my server is die. I'm going to also make a return here. And over here, I'm going to say return 0. That's very strange. Okay. I want to print the pointer value for this argument because it seems to me I'm not getting my expected value for PTR RET. So I'm going to print it this way. Okay, I'm going to not worry about the client. Apparently my pointer is getting me a 0. That's very interesting. Why they're getting me a 0? Oh, I know. Okay, I know. My logic is okay. I'm going to fix this. I'm sorry. I realized what mistake I made. This one need to be star. Okay, I forgot I need to have a 2-star in order to make this to work. Now I think I have to change this part to be GPS PTR 2. And then I can do this. Then the rest should be okay. Now I have to change again, shadow dot H. Again, see that? Okay. Why the network is not so reliable? I'm sorry about that, student. Okay, I have to change this part again because I just make the mistake. Even for me, I make a mistake quite often. So this has to be star star. And then the CPP has to be star star as well. Teaching. All right, fine. It's coming back. Okay, over here is going to be star star. And over here, I'm going to do this. This is kind of interesting. Star return pointer is equal to this. Can I make it? What is this? This is, okay, label GPS. Again, I have to modify label GPS. Yeah, I hate this kind of online programming. It sometimes has issue, then I have to fix all this bug. Okay, almost there. Set GPS label, put it star star GGG. Okay, finally, I got this part and now I'm going to run the program. Okay, now you can see I generate, finally, this is what I want. Is that, okay, sorry for all the trouble, but I'm just showing you number one, your instructor sometime is himself is take some time for me to make something happen. But what I just did, I want to show you if you are interested, if you follow what I did in the past 10 minutes, I'm actually converting a piece of code which include the exceptional handling, the standard C++ exceptional handling into a piece of code which I remove all the try, catch, and throw. And then I managed to generate the same result. Okay, it's not quite there, but that's the process I've been to. So then my original question, why I did this, is I tried to argue with you that why is unnecessary, is not needed for us to do exceptional handling. Where's my PowerPoint? It's here. Okay, my favorite PowerPoint. Okay, here. So my question to you is, why do we need exception? But I think what just happened through that 10 minutes, including like a 2 or 3 internet disconnected operation, you actually see that it took an effort for me to remove throw or remove the catch and passing the information between two functions is not that easy. I mean, even though I made it happen in 10 minutes, but that was the very simple case. If you have a more complicated case to handle the exception condition, then the piece of code is not just 10 minutes I need to modify. It probably takes months, several months plus to do the multiplication. So I want to tell you that why, I want to ask the question in another way, is that, well, then why do we need exceptional handling? The reason we need exceptional handling is that we want to separate what we call the normal and the otherwise. So what's a normal? Normal means that when you write a program, you actually expect this program need to handle those mostly common cases in your input information. So that's a normal case. But then you always have to deal with otherwise, which is something which is out of your expectation. I shouldn't say out of your expectation, because when I say out of your expectation, means that something is unexpected. But it's not. It's usually saying that is anything that's not normal that you can actually think about it's otherwise. And then with otherwise, you use the exceptional handling to handle that. So essentially, your program now has two parts. One programmer think about what's the normal case. And another programmer think about otherwise. This is about separation. By the way, this happens so often in real programming environment. That's why if there's a very important message you need to learn is that object-oriented language is always designed for teamwork. You have multiple programmers. One of the programmer, he knows the normal case very well. He defined what's my program, I need to deal with a normal case. But there are other programmer that's going to look at his code saying that, hey, you didn't handle this, you didn't handle that. So of course, you can actually pass on the information for the first programmer to tell him, hey, you need to consider this, you need to consider that. And that becomes a very tedious conversation when you do the teamwork. But the other way to look at this is very simple, is that, okay, I only care about the normal case. And anything is abnormal, I will dedicate it for exceptional handling. And I have the other programmer worry about all the catch clause, recover, catch, everything. So that's the real power about exceptional handling. Allow us to separate the control from one single programmer to multiple programmer. This is something which I will show you the example. Okay, so now I'm going to tell you the next topic I'm going to talk about. What we talk about is that in exceptional handling, first you have to detecting that there is an abnormal situation you need to handle, and then you have to recording the exception related information. For example, I said, okay, you are doing bubble sort. You're in the middle of bubble sort. That means you need to record whatever you process. So the other programmer can worry about the what I call continuation of exception, because you're going to do a big jump to somewhere. And somebody which need to repeat some of the stuff and some of the part they might be able to skip. And so that's the things about the general exceptional handling. So the next thing I'm going to talk about is what I call a object-oriented style of exceptional handling. So we have talked about the general idea about exceptional handling. Then we're going to talk about a object-oriented style. Means the exception itself is exception. Let me show you one example before I let you go, and then see you on Thursday. If you go check one place, on my computer is under, you should find the file, library, developer, command line tool, SDK, Mac OS 14.4.SDK/user include C++ version 1 exception. Okay, I have this exception file. any environment, C++ should have this line. And I want to tell you what this file is. This is a standard C++ exception. So instead of throw an integer, throw a GPSDD, you can actually throw a particular exception, which is defined by the C++ language. So think about this. I show you, this is the standard class exception. Sorry, I have to move this a little bit up. You can see I have this exception itself is a class. It has a constructor, and it has operator overloading, and it has a destructor, which is a virtual function. And it always has a function called what. What is conveying the exception information. So what is a standard? So basically, this is the basic standard exception. And then you have a class, that exception is inheriting from public exception. So it's standardized exception and they use inheritance. Give me one more thing. I want to show you this. This one is the other exception. This is actually not the standard exception. Oh, sorry. I want to get rid of this. This one is actually an exception file from JSON RPC CPP. That's the one you have been seeing sometime if you follow the code. And take a look at this. This is a JSON RPC CPP exception. It defines a class called JSON RPC exception. It is also inherited from STD exception. Okay, now we're going to look into the code to see that how C++ design a bunch of classes with single inheritance, with virtual function to actually implement the whole idea about exceptional handling. Let's continue this topic on Thursday. And remember tonight, 7, right? I said 7 to 9 p.m., right? I will be in Qiguan building, 4th floor. And if you cannot get into the Qiguan building, I will just send a line. I will go downstairs to open the door for you. Okay? All right. Any question? Okay, see you.